क्लास 12th का चैप्टर है रिलेशंस और फंक्शंस। कॉन्टिन्यूड सीरीज चल रही है। चलिए फिर से शुरू करते हैं। फर्स्ट चैप्टर है क्लास 12th का। एक्सरसाइज नंबर 1.3 है। क्वेश्चन नंबर 6 से हम शुरू करेंगे आज। फर्स्ट पार्ट अगर आपने नहीं देखा हो तो आप व्हाट्सएप कर सकते हैं, रिकॉर्डेड लेक्चर्स आपको मिल जाएंगे। आई एम गोइंग टू शेयर माई स्क्रीन अलॉन्ग विद यू। ये आप एक्सरसाइज है, देखिए 1.3। 5 क्वेश्चन तक हो चुके हैं। अब आज हम शुरू कर रहे हैं क्वेश्चन नंबर 6 से। चलिए शुरू करते हैं। क्वेश्चन क्या है? शो दैट एफ, उसके जो इंटरवल है -1 से 1 तक है, एंड एफ एक्स फंक्शन जो आपका दिया हुआ है x अपॉन एक्स प्लस 2 इट इज 1 1, ये शो करना है। और फिर उसके बाद हमें इसी फंक्शन का इनवर्स निकालना है। तो चलिए अब इसको हम शुरू करते हैं। आई एम गोइंग टू स्टार्ट। I bring the question over here. Now this is the question. चलिए क्वेश्चन को शुरू करते हैं। आपको ये शो करना है कि ये एक 1 1 फंक्शन है। तो आप किस तरीके से शुरू करेंगे? वही पुराना चीज़, एफ एक्स इज इक्वल टू एफ वाई लेकर के इसको हम शुरू करेंगे। तो सॉल्यूशन इसका है नाउ फॉर द सॉल्यूशन। आपका ये जो इंटरवल दिया हुआ है ये आपका दिया है -1 से 1 तक, एंड फंक्शन आपका जो दिया हुआ है इट इज गिवन एज x अपॉन एक्स प्लस 2। तो लेट एफ एक्स इज इक्वल टू एफ वाई। 1 1 फंक्शन के लिए हम इसको 2 एलिमेंट्स ले लेते हैं। तो चलिए इसकी वैल्यू सब्स्टिट्यूट करते हैं। तो x अपॉन एक्स प्लस 2 विच इज इक्वल टू y अपॉन वाई प्लस 2। चलिए इसको सॉल्व करते हैं। हमने क्रॉस मल्टीप्लाई किया, x y प्लस 2 विच इज इक्वल टू y x प्लस 2, दैट इज एक्स वाई प्लस 2x एक्स वाई प्लस 2y। एक्स वाई आपका कैंसिल हो जाएगा। 2x इज इक्वल टू 2y, 2 and 2 get cancelled, we have x is equal to y. Now we easily see that fx is equal to fy, and also we get x is equal to y. So this function f is 1 1 function. This function is said to be 1 1 function. Now we can say that -1 to 1 range of f is exist. Range of f exist. So let we find the inverse for that. Let there's any function g which is range of f, that is -1 to 1, be inverse of f. Then we find the inverse y is equal to fx for some value of -1 to 1. So now which is equal to y is equal to x upon x plus 2. Now we cross multiply, we get xy plus 2y is equal to x. So come over here, xy plus 2y is equal to x. So we can bring xy on the right hand side, take x common, it becomes 1 minus y. So we can write this is 2y. Yeah. So that is value of x becomes 2y over 1 minus y. Now we can easily find the inverse over here. Now let us define this range. So when this is equal to this, then y should not be equal to 1. Otherwise it becomes undefined. Now we have to check. I'm going to write over here. I'm just making a blank line so that it can't be mixed up. Now let us define the g function, that is zy. We get 2y upon 1 minus y, which we get over here. Now try to find the GOF operation, which is equal to g of operation of f of x. Now which is equal to g of x upon x plus 2. This is the f function. You can see x upon x plus 2. Now we put this value in this inverse function. That means in the g function. This x upon x plus 2, this is the value of the fx, which we put into the gy. So which is equal to 2 into, in place of y we write x plus 2, and here 1 minus x upon x plus 2. So it becomes 2x. You can see x plus 2 can get cancelled. X plus 2 minus x. Simply x and x get cancelled. And we get 2x by 2. It is also get cancelled. It becomes x. So now from here we can easily see that GOF of x is equal to x. Now we check for fog also in the similar manner. That means f of operation of gx. Now f of operation of, for the gx we write 2y, because it is the value of gx, 2y minus 1 minus y. Now we put this value in the function of fx. Function of fx is x upon x plus 2. Listen, fx is what? X upon x plus 2. And gx is what? 2y upon 1 minus y. So now we put in this function x upon x plus 2, that is 2y upon 1 minus y upon x plus 2, that is 2y upon 1 minus y plus 2. Now we solve that. It becomes 2y upon 1 minus y get cancelled, 2y plus 2, 1 minus y. It becomes 2y over 2y plus 2 minus 2y. It is get cancelled. And we get 2y by 2, 2 and 2 get cancelled, and it is y. So when we solve for that, we get y. So from here, we can see that it is an invertible function. So we can write that f inverse of y is equal to 2y upon 1 minus y, but y should not be equal to 1. This way these types of questions are solved. Now next question we have question number 7. This is the function. We have to show that it is the invertible function and we have to find the inverse of a function. Actually, invertible function is very important. It is generally asked in the examination. So please prepare this question. So in order to prove whether a function is invertible, we have to prove it is 1, 1 and it is onto. So solution. Now relation condition is given to us. Okay, function f is given to us r dot r relation, and function is given like 4x plus 3. This is the function. So firstly we have to prove for 1, 1. So let it be fx is equal to fy. So we can write 4x plus 3 is equal to 4y plus 3. 3 and 3 get cancelled. So 4x is equal to 4y, 4 and 4 get cancelled, x is equal to y. So it proves that function f is a 1, 1 function. I think you understand clearly how will you prove the 1, 1 function. Now for the onto. Now for y belongs to any element belongs to R, let y is equal to 4x plus 3. We equate with it y in place of fx. Okay. So when we solve, it becomes y minus 3 is equal to 4x. So value of x becomes y minus 3 by 4. Now we have to check fx is equal to function of y minus 3 by 4. Now we put this value in the function. In which function? The main function is what? 4x plus 3. So that is 4. In place of x we write y minus 3 by 4 plus 3. 4 and 4 get cancelled. It becomes y minus 3 plus 3. It is get cancelled, which is equal to y. So f is onto. So that f is onto. So when it is 1, 1 and onto, there exists an inverse. If any function is 1, 1 and onto, its inverse, that is f inverse, exists. So now we have to check it. Actually I am using this portion. I am not going to change the paper because we need over here some different values. Now value of gy is equal to what we have find, that is y minus 3 by 4, and value of fx is equal to 4x plus 3. Now listen, for example, if we find the value of cof, which is equal to g of fx, which is equal to fx, that is 4x plus 3. This fx, then this is fx. Now we put this value in the gy. So 4x plus 3 minus 3 by 4. Let us get cancelled. We have 4x by 4, which is equal to x. Now we observe the value of fog, that is function f, then gx. Then what is gx? That is f of y minus 3 by 4. Now we substitute this value in this function, 4x plus 3. 4 in place of x, we write y minus 3 by 4 plus 3. Now it becomes 4 and 4 get cancelled. Y minus 3 plus 3, which is equal to y. So from here we see that value of function fx is equal to y. So when we find GOF, or we can write a statement like this, GOF is equal to fog is equal to I. You can see also ig, invertible function. So we can write inverse of f, which is equal to gy, which is equal to y minus 3 by 4. This is your answer. भैया नहीं है? हाँ हाँ, वहीं छोड़ दीजिए अभी. Now next question. Question number 8. Now here the intervals are different. Let's start again like that. Function f is given as r to infinity. Now fx is equal to x square plus 4. So for 1 fx is equal to fy, that is x square plus 4 is equal to y square plus 4. So from here we can see 4 and 4 get cancelled. X square is equal to y square. That is, we can say x is equal to y. That is, function f is 1 function. Now for the onto, we have to find the inverse. For the onto, y belongs to 4 to infinity. So y is equal to x square plus 4. So x square is equal to y minus 4. So from here, value of x is equal to under root y minus 4. Now, for any y belongs to the real number, there exists, वहीं रहने दीजिए. हाँ हाँ, belongs to R. So we can write fx is equal to f of, we get y minus 4 under root y minus 4. So if we put this value into this expression, so it becomes under root y minus 4 whole square plus 4, which is equal to y minus 4 plus 4. It is get cancelled and we get y. So we can see that its inverse is possible. So f is onto function. Now gy is equal to under root y minus 4. So we just find the value of GOF, which is equal to g operation fx. That is g. What is the value of fx? Value of fx is x square plus 4. Now we put this value in the function of gy. That was this one. Actually, this value, this is fx, and inverse this becomes gy. So we substitute x square plus 4 in this, x square plus 4 minus 4. It is get cancelled. That is under root x is equal to x. So now we go for fog, which is equal to f operation g operation x. So f, what is the value of g? That is y minus 4. Now we put its value in the x square plus 4. That is under root y minus 4 whole square plus 4. Now we use this for the function of fx. So it becomes y minus 4 plus 4, which is equal to y. So we can see that GOF is equal to fog is equal to invertible identity. So f is, we can write f is invertible function and inverse of f. That means you can write f inverse y in this way is equal to gy is equal to under root y minus 4. This is your answer. Question number 9. Okay. 9, 10, 11, 12. From question 9 to 13, I will do later. And I do this question over here, 13 and 14. Now, FOF, 3 minus x cube to the power 1 by 3. Now, FOFX. which is equal to 3 minus, in place of x cube we write 3 minus x cube 1 by 3 to the power 1 by 3. Now which is 3 minus 3 plus x to the power 3 1 by 3 to the power 1 by 3. Just get cancelled. So this is also get cancelled. We have x to the power 1 by. Now next question. Sorry. We have to find the inverse. Just go for here. Put y is equal to 4x 3x plus 4. Solve for it. Y into 3x plus 4, which is equal to 4x. 3xy plus 4y, which is equal to 4x. So 4y is equal to 4x minus 3xy. Take x common, 4 minus 3y. The value of x becomes 4y upon 4 minus 3y. So this is the value of gy. This is your answer. So now in the next lecture, the last lecture for this exercise, I will go for 9th, 10th, 11th and 12th. Till then, bye. Thank you for watching us.